Hello my dear students, here is the third lecture of microwave engineering lab. In previous lectures we have came to know different type of microwave devices. There are some list of the devices we have to know. First of all, there are some matched terminator. This matched terminator is essentially a matched loop to a microwave transmission line. As the standing waves occur due to impedance mismatches, uh, the system the matched terminator is to minimize the SWR. That means it is used to minimize the standing wave ratio in a system. Okay, so this part, that is, you can see there is a rectangular waveguide, and that has been put through that has been adjusted to another part, just like this. So this is one of the matched terminator, and that is connected with a rectangular waveguide. And another part is the coaxial adapter that provides a match between a waveguide and a 50 ohm coaxial line, 50 ohm coaxial line and a waveguide. The power flow can be in either direction. That means it can go through there and go in out. However, the adapter should be kept less than 1.2, and that is gonna be the it's gonna be the parts that we have to know. And there is another thing, so we have to see, we have known from the theoretical point of view. There's a magic T or hybrid T. A magic T is a 4-port device which is basically a microwave version of a hybrid coil of the type commonly used in telephone repeater circuits. It has the properties that when properly terminated in external impedances, power incident on any arm splits equally between the two adjacent arms, but there is no power coupled to the opposite arm. The Magic T is an essential device in balanced mixers, automatic frequency control circuits, and impedance measurement circuits. The reflecting sheet, that's the reflecting sheet, a mean of the reflecting electromagnetic wave in free space when measuring the wavelength of a signal. Shorting plate, when measuring the wavelength inside of a waveguide, a shorting plate is used to create a short zero impedance at the open end of a waveguide. That is a waveguide straight section. That is a 6-inch straight section of waveguide used in measurements of the wavelength and the phase velocity inside a waveguide. And that is the usage, cares of use in this waveguide. So first of all, in order to improve the measuring area reliability, the connection of each microwaves should be made correctly, should adhere to the following rules. So there are some safety issues we have to keep on our mind. The central rectangle of waveguide should be kept in a line and the edge should be matched. Two flanges should be tightly joined with 4 nuts so that the microwave doesn't leak. So you have to keep the connection quite tight, that it shouldn't be leaked. The second one is the component of this experiment set should not be used for any other experimental purpose. No drop or shock should be applied to every component. Keep away from humidity or heat. Should avoid to use a dusty area and should be kept in its storage case after use. And check whether any foreign substances is attached on the entry and exit waveguide before the assembly of the experiment circuit, construction of components, and remove the foreign substance if existing. While the oscillator is oscillating, the internal part of oscillator must not be observed through the output part. Because the oscillator and this experiment unit is a relatively small power, the output is not dangerous to the body parts, but eyes can be permanently damaged. So we have to keep our eyes safe from the microwaves. That is an important thing. Now there are some in and out component that how the directions can be made through it. So first of all, there is an experimental, there you can see there is an experimental, you can see that experimental setup of a microwave waveguide or microwave components, that among 15 kinds of microwave components within ED3000, that is our kit that we have to use here while measuring the microwave outputs and inputs. The input and output wave codes is classified as in the following: slide screw tuner, slotted line. These are the two parts, that is the slotted line and the slide screw tuner, that really holds greater space in measuring the microwaves. The above two kinds hold sliding location 0 to 40, and that can slide through there. And since the flange with 0 on this adjustment scale becomes input, the flange with 40 scale becomes output. Okay, it means the slide screw from the 0 to 40, 0 means the input, the 40 means the output scale. The connection should be made correctly according to the experiment and route. So the following picture shows the connection sample of slotted line. That is the connection sample of slotted line that you can see here. And it's an experimental setup. There is a horn antenna, you can see here in the microwave output side, and there is that is the slotted line position, and there is the in position. In that there is a gun oscillator that puts the microwave through to that, and then after getting the measurement of slotted line, it will go out through the microwave horn antenna. So the use of components with directions. Among microwave components, there are components which has the preset connection directions. These components are not transmitted in one certain direction and send the wave only to a specific direction. The following components: inverse direction. Now we can see there. Now that is the pictorial definition of directional coupler and magic T. You can see here in that part, that is a directional coupler. So the horn antenna has been kept in the collinear arm, and there is another arm, the adjacent arm that is go up there. So if the power input go through to that position, once the power go through to the output position, and other part will go out up on that, that is the receiver part. If in the receiver part as an input, so there will be no power there that you can get from that second, that means the directional coupler's adjacent arm. So the directional coupler of the picture shows that in the case that the wave enters to P1, the same P1 wave is transmitted to P2 and P3. However, picture B shows that the opposite case of A, which is the enters through P2, that means the output position. Although this wave is transmitted to P1 from P2, it is not transmitted to P3. P3 means the adjacent arm. If using these characteristics, one microwave antenna can be made, transmission, reception and the reflection in the waveguide circuit can be detected. That is all for now. Thank you very much.